In the last class, we have seen the basic operations, right? Basic operations of relational algebra. Okay, so the reason why we discuss the concept of relational algebra is, so this is the basic concept for to write SQL queries, right? So before going to write any kind of SQL queries, first you have to know the basic concepts of relational algebra so that you can able to easily convert the relational algebra into SQL queries, right? First, before going for this writing SQL queries, we require first database, right? We require database. How we are going to create the database? By using database schema. By using database schema, I mean you are going to get the requirements from the client. Client will all those will be analyzed. Then you are going to design it. From the design phase, you are going to get database schema, right? So here I am going to take a simple example for you. So one is a company database. Okay, so this company database requirement is there. This requirement is already given to you, which is in the lab. I think you have drawn also, right? So like this you are going to do, right? The entities are here: employee entity, department entity, project entity, family members entity, right? And if you would like to define the relationships, the same thing what you are going to draw, right? So employee department relationship is there, and employee department works for relationship is there, department product relationship is there, and employee relationship is there, employee products relationship is there, and employee family members is relationship is there, right? So by analyzing these all the things, you can able to uh, you can able to draw the ER diagram for it, right? If you are able to observe this one, this is the respect to ER diagram for the given requirement. This is already completed by you, right? I have given the lab. Okay, fine. So once we draw an ER diagram, you can able to convert it into the respect to schema. This is what you can call as company database schema, because we are not going to represent in the form of tables, we just represent in the form of structure representation. We call it as a company database schema. Okay, from this company database schema, we can able to define the foreign key representation also, right? This is also what we have seen in the earlier classes, right? With this one, you can able to insert, we can able to create the database in the actual database, and then you can able to create the data like this. I hope you observe, right? If you are able to observe here, employee is one table where it contains first name, middle name, last name, SSN number, birthday date, address, gender, salary, super SSN. Super SSN means for every employee there will be supervisors. We can call it as super SSN, meaning that their supervisor IDs are given and the department number also given, meaning that in which department they work, right? And the department table contains department name, department number, manager SSN. Manager SSN means who is the manager of the respective department, and from which date he started working in the department as a manager, right? And family, meaning that dependence family. If you observe the dependent family, ESSN, dependent name, gender, relation, meaning the ESSN means employee number. For that employee, the dependents are so and so persons. They are male or female, and their relationship, who is father or daughter, son, or whatever it may be, right? And in which project they are working, like what is the project name, project number, project location, department number. And if you observe this table, department locations, in which location the department is existed, right? Department number, department location, works on, which relation defines ESSN number, project number, and total number of hours it is working. Okay, this is what we can draw on by observing this corresponding requirement, right? As you studied this earlier, I am not going to read once again. Okay, fine. So with this one, I am assuming that I am having a database instance. What is the meaning of database instance? Collection of tables, all those tables information at a particular amount of time. I can call it as database instance. So technically I will call it as, here also I have written database instance and the. Okay, so with this database instance, I have available my database schema, and my database is also available. Now on this database, before applying SQL queries, can I apply relational algebra or not? Yes, I can able to apply the relational algebra. So, so we can have various kind of queries are there. Those things we'll discuss right now. Try to observe now. See, the same table I have given there, and write a relational algebra query to find the employee details who are working in department number 5. Can you write the query for this one? Yes. Try to observe. The question here is you need to find out all the employee details who are working in department number 5. Right? All the employee details are available in employee table. In the same employee table, do you know the department number? Yes or no? Department number 5, right? If you would like to find out the employee details, all the employee details are available in one particular table called employee table. This particular table itself having one attribute called department number, right? If I am going to give the department number 5, can I able to get all the details or not, right? So what is the query you can able to write? I am trying to ask to get the data, right? If I am trying to ask the get the data, can I use select operation? Select from which table you need to get? Employee table you need to get. On what condition? Department number equal to 5. This is a simple query you need to write in order to write the query for the requirement. Okay. Next one, find out the SSN of an employee whose gender is male and whose department number is 4. Can you able to solve it? Yes. Right. On the same table, you are going to have a gender. On the same table, you are going to have a department number. Right. So you can able to simply write select whose department number is 4 and gender equal to male, and which table? Employee table. That's it. Okay. Next one, find out the first name and the last name whose salary is between 18,000 and 30,000. Right. First, can we able to get all the details of the employees whose salary is between 18,000 and 30,000? Yes or no? Right. Salary is available in the same table or not? Salary is available in the same table. So I can able to simply select all the employees whose salary is greater than 18,000. See, and means you have to write capital A and D, and salary is less than 30,000 from which table? Employee table. Okay. So here what data we are getting? We are getting all the details, but what data they are asking? They are asking for only first name and last name, right? You need to filter it based on the columns now, right? How, what you can do simply, you can simply perform project. What is the data? F name, comma, L. That's it. This is the query for to represent to solve the third question. Next, take the fourth one. Find out the SSN of an employee. SSN employee who work in department number 4 or supervisor of an department number 4 employee. Try to read 1 to 2 times so that you will get clarity. So here you have to consider two scenarios. Who are working in the department number 4 is one scenario, right? Can you able to find out? See, there is a terminology called OR. You can simply understood, right? So first, can you able to find out the department number 4? Can you able to find out the SSN of an employee from department number 4? Select who are working in department number 4 from the employee table. Employee table. From this, can you able to project SSN? So this represents the first part. Find out the SSN of an employee who work in department number 4. First part is solved. What about the second one? Or supervisor of an department number 4 employee. Supervisor of an department number 4 employee. Right? Who are the department number 4 employee supervisor? Right? Is there anything is there available? For department number 4, for department 4, the employees are, for department 4, the employees are Mithali and Rohit. And for these supervisors are what? 534 and 538. And for Kohli also supervisor, right? That is 534. 534. So then what you can write? What you can do? You have to select the department number equal to 4. The department number equal to 4 from employee. What you have to get? Supervisors you have to get, right? I am going to get project of super SSN. Super SSN. Now I am going to simply combine these two. I am assuming that this is T1 and this is T2. What is the resultant relation? T1 union T2. That's it. Simple thing. I am trying to find out the SSN of employees who are working in the department of 4 or their supervisor SSNs. Or, so they have clearly mentioned or. So that's why you are going to get this one. Next, find out the employee SSN whose salary is either 15,000 or 26,000. What is the meaning of this one? You have to simply use OR operator, right? So you are going to have two queries. One is for project of SSN, where their salary is 15,000. Can I write OR operator here itself? Or salary is 26,000 from employee table. That's it. This is the query for the respective thing. Or you can use the another way. What is the another way? You can use the another way as T1 union T2. What is T1? Trying to find out the employee SSN of who has salary 15,000. T2 is finding the SSN of an employee who has salary is 26,000. And finally, I am going to combine T1 union T2. I can write it, right? So here I have written projection. Why projection? They are specifically asking for only employee SSN. Right? Next one, find out the employees who are common to department number 4 and whose supervisor is 534. Find out the employees who are common to department number 4, and whose supervisor is 534. Just try to check. So just you have to apply the simple and condition, right? Because see, when you are going to think about cross product or join or natural join or whatever it may, when you are going to consider, when your data is between multiple tables, then you think about joins. But when they are asking about department number 4 and supervisor, both are in which table? On the same table. So there is no need of concept of applying joins simply, right? I am going to simply find out all the employees whose department number is 4 and whose super SSN is also 534 from the employee table. Is it correct? Yes or no? That's it. Or what is the other alternative for AND operator? Intersection. You have to go with the intersection operator, right? Try to think. I am trying to write like whose department number equal to 4 from the employee table, and whose super SSN is 534 from employee table, and between these two I am going to apply intersection so that you are going to get the common data. Okay, na? So meaning that for AND operator intersection you have to use. For operator you have to use union operator. Next one, find out the employees who didn't allocated any work in the company. Find out the employees who didn't allocated any work in the company. How we are going to get this data first? So in works on relation, if you observe, there is an employee SSN. Meaning that if the data is available in ES works on, meaning that they are the workers working in the department. They are workers working in the department. So they are asking for the employee details. Right? At the time, what you have to do? You have to combine works on and the employee table. Works on and the employee table, right? How we are going to combine? By using join operation. Okay. But here what they are asking? If you want all the details, then you have to go for join operation. But they are asking for only find out the employees. Simply we can assume it as employee ID numbers. Right? So these are the employees who are working. These are the employees who are available. From available, if you are going to remove who are working, can we get the who are not working? Who are not working? Can I say that P minus Q operation? Yes or no? Yes, I can do that. Right? You can simply write. So from the actual table, I am trying to project the SSN. Project the SSN. SSN of employee table. I am assuming it as T1. T1. And from the works on table, I am trying to get employee SSN. I am assuming it as T2. T2. And if I am going to perform T1 minus T2, what is the meaning of it? The people who are not working anywhere, are you going to get or not? So, for example, if you want to get all the data on this T1, you can able to perform the data. Whatever thing you require, you can do. Find out the employees who are managers of the department. Find out the employees who are managers of the department. Right? Here asking the employee details. Right? Employee details are available in employee table. And department details are available in another table. And who is the manager? Manager SSN is available here. Now what you can do? You need to combine these two tables in such a way that manager SSN is equal to employee SSN. Am I right? If manager SSN is matched with SSN, then I am going to produce the respective details. Okay now? Fine. Now can I use join operation here? Sir, okay. Without join operation, can we get it? How? How we can get? We need to do it separate queries, right? T1 is one separate query, T2 is one separate query, then we can go with the intersection operation, right? Or else can we go with the join operation directly? And join operation is going to do what? It is going to join the two tables into single table by making all the related tuples into a single line, right? So can we get the data or not? Yes, we can do it, right? So what we can do? Can I do like this? Something employee theta join or theta join on what data I am trying to do? SSN is equal to where I need to check for this one? Manager SSN on department. Right? This I can consider as a one relation. Right? If they are asking about like names only, then what you can do? Project of first name comma last name on the center relation. Okay. Next one, find out the employee SSN who are not managers of any department. Not means you have to think in terms of negation. Who are not managers of any department, right? So if you know managers, can we get the non-managers? Yes or no? So then what you can do? Can I subtract? Can I remove the data from employee SSN minus department SSN? Yes or no? We can get it directly, right? What you can do? So I think this query is related to the 7th one, right? So simply I am going to project all the SSNs from employee table, from which I am going to project manager SSNs from department table. I am considering it as some relation or this R contains now what? All the data who are not managers. Is it okay? Next one, try to think 10th one. Find out the employees who are not supervisors of a company. What is the meaning of this one? Supervisors is available in one location, SSN is available in one location. From SSN, if you are going to subtract supervisors, they are not supervisors, right? Non-supervisors, right? Simple thing, the same as the previous one. Projection of SSN from employee minus projection of super SSN from employee. Superannuation also available in the same table only, right? If you are going to get the data, that will comes under all the employees which are not supervisors, right? Find out the employees who are not supervisor and who are not managers. This can be done in multiple ways, right? First, what you can do, you can find out all the non-supervisors, and then you can find out all the non-managers. Then you can apply and operation. That is one solution. Or is there any other operation you can able to do? Try to do that, right? So first I am trying to find out the non-supervisors. Who are not supervisors? I am considered as R1. R1 is non-supervisor. Okay. Next, if you look into the previous query, not managers are also there. I am assuming it as R2. I am using the not managers also there. This is R1. Then if I am going to perform, find out the employees who are not supervisors and not managers, right? So then what operations we need to apply between here? Intersection. Can you able to apply intersection or not? And operation R1 and R2. Both has to do. If you are going to make R means what? Who are not managers or neither are you are going to get. But I need to have only and operation. So that's why R1 and R2 you are going to get certain relation like or. Okay. Guys, can you think that R1 minus R2 is valid? No. Right? It means what? This is completely different. Who are who are who are not supervisors but not managers. Who are not supervisors but not managers. But managers. Huh? Okay. So these are not managers. These are not supervisors, and these are not managers, right? How can you do this one? I am trying to check about the things who are not supervisors, but not managers. Is it correct? See, what is the meaning of A? This one, which are in A but not in B. So the same sentence replace you, right? Who are not supervisors but not managers. Simple thing. Huh? Okay. So the that is a solution for this one. A. So if you are going to define like R1 minus R2, who are not supervisors but not defines managers. Okay. Okay, you can read that. So this is okay. Anyway, finally here I can conclude that R1 minus R2 is not the correct solution for this query. Okay, fine. Next one, find out the employees. Find out the employees who have insured in a company. Who have insured in a company. It's all the simple one, right? Insurance details available in which location? Family. Employee details available which location? SSN, right? Insurance means what? Right? If I am going to find out, so these are the things like who are make insured. These are the persons who are employees. Employees. There are certain employees who may not insured. So from employees, if you are going to remove the insurance data, what you will get? Not insured will get. But you need what? Insured. Insured is where location? Which location? There itself. You can simply project the respective table. Project of SSN of family. Right? So what does this meaning? Not insured or insured? insured, right? But here assume that the question is you need to find out the data employee data, then our query will completely change, right? So this is one new relation. From this new relation can be able to perform natural join on what? Employee. If I am going to perform natural join, what is going to happen? All these numbers is going to be natural join with the employee table. Then you are going to get all the respective details. Yes or no? Yes. Next one, retrieve the name and address of all employees who work for playing department. Right? Playing department information available in department location, and name and address are available in one location. Then at this situation compulsory what you have to do? You cannot able to do it with the basic operation. You have to compulsory go with the like join. Cross products also you can go, but that is not the correct way. You can go with the, so for cross product alternative way is joins. So you can go with join operation. Right? If you are going to go with join operation, on what date you can join? Because the common thing between these two are what? Department number. See, SSN is there, but this SSN is different from that SSN. This is manager SSN, this is normal SSN. So you can go with the department number. So first what I can do, ma? I would like to find out the department number. Can I find out the department number? Yes. Uh, department number name equal to playing. Department name equal to playing. From which thing? Department. I can do this. Right? Now, what did I got? I got the department numbers. And these department numbers I have to do it with what? Join with employee table. Join with employee table, right? So this is, I can write here as department number equal to D number. Is it okay now? I made it in a single query. Employee theta join of department number equal to department number on this particular thing. So then you are going to get all details related to playing data, right? If you are not going to write this relation, what is the meaning of it? Is there any particular meaning for it? No, I am trying to simply aggregate the respective details in the respective department playing details. Like it's not playing, it's the department name details. Okay, now. Right. Or else, what is another way? Is there another way? Is there? You can simply write it as separate thing. One is T1, another one is T2. Then you can perform T1 natural join on T2. You can do like that also. Next, for every project located in Kadapa, list the project number, project names, controlling department numbers, and department manager, last name, address, and date of birth. Right? So every details are available in different kind of locations. Try to think. For every project located in Kadapa, what they are asking? They are asking for the details, the projects which are available in Kadapa. Kadapa location is which one? Project locations is available in the project table. So you have to first find out the project numbers from this one, right? What are the project numbers of the project location? How can you do that? Product of project number from. So you have to make here what? Select operation. Select project number. Sorry, what they have given here? Project location. P location equal to Kadapa from project table. So are you going to get the project numbers? Yes. We got the project numbers. For that, project names also available. So you can able to get like project names also we can write. Project numbers, project names you got, and their controlling department numbers. What are their controlling department numbers? 5, like, so all these department numbers are available. So I can directly write department numbers also. and their department managers we need. Their department manager list is available which location? Which is in another table, department table. Now this result I am thinking that as T1. Think it as T1. Now compulsory T1 should be joined with what? The department table. Department table which on what base you can do? On what base you can do? You can do it with the department number, right? T1 department number equal to D number of department department. Now we got what? Managers. Now we got managers. On this one, what they are asking? Their last name, address, and date of birth. On this one, you can able to once again join them as what? Their SSN, right? Then what you can do? Manager SSN equal to SSN on employee. So this is the final relation you need to have. I think this is also not what they ask specifically. Last name, address, and date of birth, right? So based on that, you can able to again write project query, project L name, address, date of birth, like that you have to write. What do you think? Right? So the simple thing here is, once I made theta join of three relations, what are the meaning of this one? I am going to combine department table, employee table, department table, and the project table into a single group of columns. So I got all the data at one location. Whatever data you want to project, you can able to project. Next, find out the employees who work on all projects controlled by department number 5. Find out the employees who work on all projects controlled by department number 5. Tell me, this is somewhat different. Yes, tell me, you can tell. What is the query you can do? Right? What is the meaning of this one? We need to find out the employee names who work on all the projects. Compulsory they have to work on all the projects which are controlled by department 5, right? Department number is available in all the locations, okay? But you have to know the employee who are working in the respective department number, right? So if you observe here, workson contains the project numbers. Workson contains the project numbers, and you can able to relate it with this particular table, project table, right? So all the employees and their respective department numbers, but they are asking for the employees who are working in department number 5, which are controlled by department 5. Here you have to think, right? The person who is working has to work in all projects. Right? Is there any situation where you got this kind of thing? What is the meaning of this one? Who work in P2? Who work both P2 and P3? What is the meaning of division operation? Say they has to be compulsory participate in all the entities. That is the meaning of this, right? Which is equivalent to this one. Who work in all the projects, right? Then what you can do now? You can simply write, so works on relation with, so we need to have only name of the employees. Works on relation with, what you can do means, you can simply project the department of 5 projects. First, department of 5 projects are what? 1, 2, 3. That's it. Department of projects are 1, 2, 3. Right? How can you get the first department number 3 department number 5 projects? By using select operation. Select department number equal to 5 from project table. That I am going to assume it as T1. Right? Those department numbers should be completely divisible by works on relation. Now what are the meaning of this one? I am going to select a particular SSN who has done all the related projects, right? So that I am going to think it as T2. But what they are asking, for details, right? Now on this T2, can I perform again join? What I can able to do? ESSN equal to SSN of employee. On this, once again, what you have to do? You have to project first name comma last name. First name ka last name, right? So this is the way you have to think. Okay. Next, 16th one. Make a list of project numbers. For projects that involve an employee whose last name is Sixer, either as a worker. This is either as a worker or as a manager of a department that controls the project. Think about the question meaning first. So you need to find out what first? Project numbers. You need to find out the list of project numbers for projects that involve an employee whose last name is Sixer. First, can you able to find out the list of projects that are done by the employee whose last name is Sixer? Yes or no? Right? What you can do simply? You can simply project last name equal to Sixer from employee. Okay. So you are going to get the employee details whose last name is Sixer. From this, you need to find out the project numbers. How can I do the project numbers? On this, can I able to perform natural join? Natural join with what? Works on. When works on get only, then only you get the project numbers, right? So you can do SSN equal to employee SSN. Employee SSN on works on. Now what you got so far? The list of project numbers whose last name is Sixer. Who is a worker or as a manager. So what is the meaning of this one? Either you have to do, right? So they may be worked in a project or they may be a manager. So how can you say that they will be a manager? Again, you can able to find out whose last name is Sixer from the employee table. You have to compulsory join with what? So if to find out the manager, you have to find out the department number, right? SSN equal to manager SSN from the department. Now this is T1 and this is T2. T1 defines what? Who is a worker on the project. T2 defines what? Who is a department manager. Now what they are asking? OR operation. You can simply make use of T1 union T2. OR, right? So OR manager means T2. Next, retrieve the names of employees who have no dependents. Simple one. Who have no dependents. What you have to do? You have to simply perform difference, right? Project of first name comma last name from which thing? What you have to do, ma? So I am trying to project the first name and last name who doesn't having any dependents. How can you find out who doesn't have any dependents? This is dependent data and this is all data. From this, if you are going to subtract, will you get the data or not? Right? So what you can do simply project of SSN from employee table minus project of ESSN from family table. I am going to get all the IDs who are not having dependents. Not having any dependents. From that, I am going to project first name comma last name. Okay. Next, list the names of I think names of managers who have at least one dependent. First, what we can do? Can you find out the name manager names? Can you find out the manager numbers? And can you find out the ID numbers? You can simply think who have at least one dependent, right? So first thing, simple thing, from department level, you are getting manager assistants. From manager level, from family level, you are going to get dependents, right? If you are able to find out simply under operation, what is the meaning of this one? Is it correct or not? Is it okay? I am going to find out all the manager assistants, all the manager assistants. From which table I am trying to find out? Department, natural join, where manager SSN is equal to ESSN from family. What is the meaning of this one? I am going to get the details who are having dependents as well as they are managers. From that I am going to get manager assistant. If this data I am going to Cartesian product, like I am going to do natural join with actual table employee SSN equal to this manager SSN. What I am going to get? I am going to get all the names. All the names if you want to get projection of first name comma last name. Right? See, I have written all the things in a single query. If you want, you can able to make it duplicate also. I mean, sub queries you can write. Right? So not only this is the one way to write the query, you can able to write it in multiple ways. Okay. Next one, display the total salaries of all employees. Is it possible? Display the total salary of all employees. Total salaries of all employees. Total salaries means what? Sum of all these employees. Can you able to find out? If you want to display the salary details of all employees means you can simply display. But here the question is you have to display total salaries of all employees. Mean in the meaning here is total salary means sum of all salaries. Can you able to do that? No. So far whatever things that we discussed, it is not possible. Display the least salary amount among the employees. Can you able to do that? But can you able to do it in programming? Yes or no? Basically, the above question also we can able to solve. You are going to retrieve all the employees SSNM, all the employees salaries. Simply what you are going to do? Project of salary from employee table. See, this is not project I think. Project. Project of salary from employee table. You are going to get list of salaries. And every time you are going to iterate and you will get the summation. This is one way. And what about this one? You need to get all the list of salaries. You are going to compare with one among each other. Something like sorting technique or whatever it may be you can do. Right? But for that, so if instead of writing the programming logic again and again, what they have come across is they have come across one more concept called aggregate functions. Okay, that we'll see in the next class. Okay, now. So if you have any doubts, you can ask me.